All right, so we're up to the next section, which is dividing whole numbers. And so this is the last part of our fundamentals kind of prereq section for algebra. And so we've looked at place value and rounding, and then identifying word phrases that represent numerical values or numerical values that we can rewrite as words. And so now we've gone through addition, subtraction, and multiplication. Finally, we've arrived at division, and so we'll continue on in the same fashion as we have been. And I would advise you to make sure that you really understand the last couple of videos to ensure that we're going into division with a good fundamental base. So division is how we can represent repeated subtraction, just like multiplication represents repeated addition. If I wanted to remove 4 of something, let's say they're cookies, and put them in each bag, and so if I was going to subtract 4, and then subtract 4, and find out how many bags I'd have at the end, a way that I could do that would be divide by 4. What dividing is really doing is saying how many groups of whatever number, in this case 4, can I get out of this other number. So in this example here on the right hand side of the screen, we can see that we have 12 cookies. And so if we subtract 4, then subtract 4, then subtract 4, we end up with 0. So at that point we can say out of 12 cookies, if I split them into groups of 4, I would then have 3 bags of cookies. So the number being divided in this cookie example would be the 12, and so that's the dividend. The number dividing the dividend is the divisor. So in this case, that would be 4. So we're looking for groups of 4 out of 12. So the 12 is the dividend, and the 4 is the divisor. And so division is only performed on 2 numbers at a time. So we want to look for the words of and to identify the divisor and the dividend. So we'll get into this a bit in some practice problems. So in terms of division notation, we can see that we have a few different notations. So we've got the first, which is the most common notation, which you'll just see the line with the 2 dots, one on either side. And then we've got the fraction form. And then we've got an a/a b. So this is basically just a fraction form as well, but we're writing it with the slash rather than separating it into a proper fraction. And then alternatively, one we don't see a whole lot, but we use for long division is this last notation here, where we've got the divisor on the outside and then the dividend underneath this kind of curly root symbol. And so the way that we can represent this can be seen here. So we've got the different expressions. And so these all mean the same thing and can be read as 12 divided by 4. Importantly, the result of a division is called a quotient. And so we say the result of 12 and 4 would be the quotient of 12 and 4. And so just a couple of quick examples to see how we can translate from math notation into word form. And so we can say 64 divided by 8 for the first. For B, we say 42 divided by 7. And for C, we say 28 divided by 4. So just like addition and subtraction can undo each other, that is, their inverse operations, division and multiplication are similarly inverse as well. And so if we need to check our answer to a division problem, we can do that through multiplying. And vice versa, if we in the last section had checked our answers by dividing after multiplying, we would have been able to get back to our original number. And so that's a way we can check. And so in this example here, if we do 24 divided by 8, we get 3. So there's 3 groups of 8 that make up 24. And so if we multiply the 3 and the 8 here, then we should get back this last number. So we get 24, and that is correct. We do. 3 times 8 is 24. So that's a really good way to check that we're getting our calculations right. So a couple of example problems. 42 divided by 6. And so I know that there's 6 groups of 7 that go into 42. So if I divide 42 by 6, I will get 7. And so I know that the result of 42 divided by 6 is equal to 7, which is the quotient. And so if I multiply the quotient and the divisor together, I should get back the dividend. And so 7 multiplied by 6 does equal 42. And so we know we're correct. So I'd like you to try the next couple on your own. I'll keep going through, but I think it's a good idea to pause the video here and have a go. So for B, 72 divided by 9. Well, I know that 72 divided by 9 is equal to 8. So I should be able to multiply the 8 and the 9 together and get back 72. And so this is a little therefore symbol. And so 8 times 9 equals 72, and that is correct. So I know that that's the answer there. And for C, same thing again, bit different notation. So this, I would rewrite this for now as 63 divided by 7. So I know that 63 divided by 7 is equal to 9. And so therefore 9 times 7 should equal 63. And that is correct, so I know I'm correct there. So just to recap, I prefer to write this either as a fraction or similarly to A. And so I don't like the notation given in C unless it's really necessary, which at this stage it isn't. And so I like to rewrite simple problems like that in fraction or just the standard form. Then, if you aren't confident in your answer, you can check by multiplying. I'd suggest while you're getting comfortable to always check by multiplying, but then you can drop this as you become more comfortable. So for division properties of 1, there's a couple of properties we need to be aware of. So that any number divided by itself is equal to 1. So if I divide 9 by 9, I would get back 1. In other words, I could say that if I was to split 9 into 9 groups, I would get 1 per group. And so 1 times 9 is also 9. And so that is always true. Then kind of similar is any number divided by 1 is the same number as itself. And so 9 divided by 1, well, it says if I split 9 into 1 group, I would get back 1 group of 9. And so that's the way that I like to think of that, and that'll also always be true. So we want to divide, then check by multiplying. So for A, if we divide 11 by 11, we would get 1, and then we should get 1 times 11 equals 11. And so that's true. For B, 19 divided by 1. So I'll just rewrite this for us. And so we would get back 19. Therefore, 1 times 19 equals 19. And so we get that correct too. So for the last one, don't get confused by the notation. So we have 7 divided by 1. And so if we do 7 divided by 1, we get back 7. Therefore, if we do 1 times 7, we also get back 7. So we're checking there by multiplying, and we are getting them all correct. So just as we had division properties of 1, we also have division properties of 0. This is a little bit more complex in a sense, but it's important as you go into algebra to understand this, and too many people don't. So the first one is kind of intuitive. So any 0 divided by any number, 0 divided by 100, 0 divided by 1,000, well, you can't split 0 because there's nothing there. And so it would end up being 0 in any case. So any number that acts as the divisor, and so if 0 is the dividend, you will always get back 0. The kind of confusing one is that dividing a number by 0 is actually undefined. And so this really comes into play a lot as we get into fractions. And so if we have any number A and it's divided by 0, this would be undefined. And so it's really important to know that. Going forward, I won't get too into the weeds with it, but just as long as you're aware that you cannot do that, and it'll just be undefined if you do. So if you put this into your calculator, which I recommend you would do, you'll get some kind of error come up. So divide, then check by multiplying. 0 divided by 3 is equal to 0. Therefore, 3 times 0 is also equal to 0. Now, 10 divided by 0, well, we actually can't check by multiplying for that one because that one is just undefined. So if you try put that in your calculator, you will get an error. All right, so going into a bit of long division here, this can get kind of confusing, so it's really important to get a good start with it. And so long division is really used when we're dividing by numbers with more than one digit. And so if we use the notation like this for long division, and so we've got the divisor on the outside, and then we've got the dividend underneath the root kind of symbol. And so just an example on the right hand side to make it really, really clear. So there is kind of a method to the process, and it's one of those methods that you will need to practice a few times before you get it right. And so you want to write down, in this example, 78 is the dividend and 3 is the divisor. And so the first step is we want to check the first digit of the dividend. So in this case, it's 7. We want to see how many times 3 goes into that. Well, it goes in 2 times, and then we have 1 left over. And so we would write the 2 above, and then we multiply the 2 and the 3. So this 3 here and this 2 multiply, and we get this 6 here. Then what we do is we subtract the 6 from the first digit, so 7 minus 6, and we get 1. Now 1 we write underneath this line, and then following that, we bring the next digit down. Now we're checking 3 and how many times it goes into 18. And so we know it goes into 18 6 times, so we go back up and we put the 6 up on top. Then we do the exact same thing, so we go 6 times 3, so that's this 6 times this 3, and we put it down here. And so we say 18 minus 18, and we get 0. And at that point, that's when we end up with our answer. So our answer will be 26. So to check this by multiplying, we could set up and say 26 times 3. And we go 3 times 6 is 18. 3 times 2 is 6 plus 1 is 78. So I'd recommend to write down these steps just as I've given you for addition, subtraction, and multiplication. It really is handy to have these besides you while you do any problems and to really ingrain the process. And so with dividing whole numbers, we really want to divide the first digit of the dividend by the divisor. If the divisor is larger than the first digit of the dividend, then we divide the first 2 digits of the dividend by the divisor, and so on. Then we write the quotient above the dividend, multiply the quotient by the divisor, and write the product under the dividend. Then we subtract the product from the dividend, bring down the next digit, and then repeat from step 1 until there's no more digits. Then we can check by multiplying the quotient and the divisor. So effectively, a lot of words, but what it means is this kind of process I just showed you, and we'll continue to do a couple of examples. All right, so the first thing we want to do is we want to set this up in the correct notation. So we want the divisor on the outside, and then we want the 2,596 underneath. And so the first thing we do is we check, all right, how many times does 4 go into 2? Well, this is where it doesn't go into 2, so we expand this to be the next number as well. So we include the 2 and the 5. So effectively what we're saying there is, how many times does 4 go into 25? And so 4 goes into 24 6 times, and then we'd have a remainder of 1. And so we put the 6 up here. So 4 goes into 25 6 times. Then from there, it accounts for the remainder automatically. And so we go 4 times 6, well, that's 24. Now we draw a line underneath, and then we go 25 minus 24, which is 1. So the next step is we want to bring down the 9, and we go, how many times does 4 go into 19? Well, 4 goes into 19 4 times. So we go 4, 8, 12, 16. So that's 4 times, and then we have a remainder of 3. So we get 4 there, and then we want to multiply the 4 and the 4. We get 16, and then we subtract 16 from 19, and we get 3. Then we bring down the 6, and we go, how many times does 4 go into 36? And we get 4 goes into 36 9 times. And so then we go 4 times 9, which is 36, and we end up with 36 minus 36, which is 0. So you should, if you're not going to have a remainder, always get 0, and then this number up top will be, in this case, 649, will be the quotient. So in other words, we could check this by multiplying, and so we get 649 times 4. So we go 4 times 9, which is 36, carry the 3, 4 times 4, which is 16, plus 3, which is 19. Then we carry the 1, and then we go 4 times 6 is 24, plus 1 is 25. And so we should always find that we get back the same number, and so this should be equal to the dividend, which in this case it is. So we know that we've done that correctly. So just to reiterate, if the first step is the most difficult to remember, and so if we're dividing the 4 into the 2, we always want to expand to the next one if we can't. So 4 will go into 25 6 times, then we go 6 times 4, which is 24, then we subtract those, bring down the next number, and then repeat that process until we get 0, or in the future we'll get some remainder. So we'll do a couple more problems. So first of all, we need to set up our problem appropriately. So we'll go 6, and then we'll go 4,506. And so we go, how many times does 6 go into 4? Well, it doesn't. So then we go, how many times does 6 go into 45? And so I know 6 goes into 42. And so I know that 6 times 7 equals 42. So that would be the closest number that we can do. And so we can put 7 there. And then we go 6 times 7, which is 42. We put a line, then we subtract here. So 45 minus 42 is 3. Then we bring down the 0. Then we go, how many times does 6 go into 30? 6 goes into 30 5 times, and it actually goes in evenly. So then we get 5 times 6, which is 30. Then we subtract, and we get a 0. Then we still have to remember, even though we've gotten a 0 there, we need to bring down the 6. And so we bring down the 6, and 0, 6 is really just 6. And so we go, how many times does 6 go into 6? Well, it goes in 1 time. And so then if we multiply, and we go 1 times 6, which is 6, and then we subtract these, we end up with 0. And so to check this by multiplying, we would then just go whatever's on top, so the quotient, multiplied by the divisor, so 751 times 6. Here, you should have this really ingrained from the last video. If not, make sure you go back and watch it and do a bit of practice. So we get 6 times 1, 6, 6 times 5, 30, carry the 3, 6 times 7, 42, plus 3, 45. And so we end up with 4,506, which is the same as the dividend. All right, I'd like you to have a go at this one on your own, but I'll continue to work on the screen. So pause the video if you want and have a go and see whether your answer matches up with mine. So the first thing we want to do is write 9, put 7263 underneath. Then we go, how many times does 9 go into 7? Well, we can't. So then we go, how many times does 9 go into 72? And 9 goes into 72 8 times. So 9 times 8 is 72. Bring that down. Subtract. We end up with 0. Bring down the 6. 9 goes into 6. Well, we can't do that. So then we need to bring down the 3 as well. And so the important thing here is that we're not skipping a place value. So because we've brought down that extra number, we need to remember to put a 0 here. So it needs to make sense there. So because we've moved over and we've skipped the tens place, we actually have a 0 there, especially when we're working from left to right, we need to put that 0 there. Then from there, we say, how many times does 9 go into 63? It goes in 7 times. Now we go 9 times 7, which is 63. Then we subtract those and we get 0. So our answer should be 807. So here, make sure you check by multiplying. So we get 807 times 9 And so we get 9 times 7, which is 63. Carry the 6. 9 times 0 is 0, plus 6 is 6. 9 times 8 is 72. And so we get 7,263, which is the same as our dividend. So by now you should kind of be getting a hang for the process. It's just about practicing, and so I'll have some more practice long division videos up where we go through lots and lots of practice problems, including application problems, so make sure you check those out too. So now on to division with a remainder. So this is a natural extension of the long division section we've just done. And so all it is at the end, we end up with some kind of remainder, and we can't continue to divide into it, so we just say that we have the remainder. So usually the notation we use is R and then whatever the number is. And so effectively, if you look at this cookie problem, if we were to divide these cookies into groups of 7, we would end up with 4 left over. And so 7, I can't make another group of 7. So we just say that we have 3 groups and a remainder of 4 cookies. So here's an example problem. We'll do a couple. So this one I'll walk you through, maybe the next one have a go. And so same exact thing as before. So we want to put our 4, and then we want to set up our long division. And so we end up with 1,439 underneath, and then we start our process. So I'll be kind of quick with this, but hopefully you can catch up. If not, make sure you practice some problems from before, as we're going to continue to move along at a good pace. So 4 doesn't go into 1, so we'll have to check 4 into 14. 4 goes into 14 3 times. 4 times 3 is 12. We want to subtract the 12 from the 14, and we end up with 2. We then bring down the 3, and we say how many times does 4 go into 23? So 4 goes into 23 5 times. Then 4 multiplied by 5 is 20. Then we subtract those, and we end up with 3. Bring down the 9. 4 goes into 39 9 times. And then 4 times 9 equals 36. So then here we get 39 minus 36, which equals 3. And so 4 goes into 3. Well, hang on a minute. 4 doesn't go into 3. And this is where the remainder problem is important. And so all we write here is, because we can't continue to do anything with this 3, we write R3. So in other words, we have 359 and a remainder of 3. So when we're checking by multiplying, the way that we do this is the exact same, but we have to remember to add back that remainder. And so if I set this up as 359, we don't write R3 here. We multiply by the divisor. So we get 4 times 9, 36. 4 times 5 is 20, plus 3, 23. 4 times 3 is 12, plus 2 is 14. So we get 1436, or 1,436. Now we add back that remainder. And so then we end up with 1,439, which is our dividend. So we don't do anything with the R3 until right at the end. So we calculate 359 times 4, and then we add back the 3. So I think it's a good idea to have a go at this one on your own. So our first step will be writing the divisor on the outside, and then writing the dividend underneath. And so we know that 13, well, this is a double digit number, so there's no point even checking the first column. We need to look at the 14 rather than just the 1. So 13 goes into 14 one time. 13 times 1 is 13. Then the remainder of 14 minus 13 is going to be 1. Now we want to bring down the 6. 13 goes into 16 one time. 13 times 1 is 13. Then we get 3. When we subtract 13 from 16, then we bring down the 1. 13 goes into 31 2 times. And then that's going to be 26. And so we work out that we have a remainder of 5. So we write 112 R5. And so when we're checking by multiplying, we would say 112 times 13. So 3 times 2 is 6. 3 times 1 is 3. 3 times 1 is 3 again. Now we have to remember to add our 0 because we're moving over to the tens. And so then we go 1 times 2. Well, because it's a 1, I know it's just going to be the number. Now, the way that I like to do this at this point is because I'm adding these together, I will just add the remainder now as well. And so I'll put a little third row and I would add the 5. And so we end up with 6 plus 5, which is 11. Then we end up with 1 plus 3, which is 4, plus 2, which is 6. Then 3 plus 2 is 5. Sorry, this should be a 1, 1, 2. And so 3 plus 1 is 4. And then we bring down that 1. And so we end up with 1,461. So it is important to be methodical. As you can see, I make errors too. And it's just important that we're aware of what we're doing and we're checking as we're going as well. So now we want to divide 74,521 by 241. So I'd like you to have a go at this one. It might look more difficult, and in effect it can be, but we have to get used to working with some larger numbers. And so we write 241 on our outside, and then 74,521. And so we can go straight to our third column. So we would look at how many times does 241 go into 745. And so when I'm working with larger numbers like this, I like to keep my calculator handy. I don't particularly feel like checking, I guess, how many times 241 goes into 745. And so the way that I would do this would I just think, what's 241 times 2? And what's 241 times 3? And you can use your calculator to help. And so I can see that 241 multiplied by 2 would be 482. And 241 times 3 would be 723. And so we couldn't get any more than that. So we would write the 3 above the 5. So because we're looking in the third column, we're looking at as a whole, we would start there. And so then we're going to multiply 241 by 3. And so we would end up with 723. And so this should be some good practice as well for the multiplication skills. And so 5 minus 3 is going to be 2. 4 minus 2 is going to be 2. And then we end up with a 0 there. So there's 22 difference there. So now we would bring down the next column. And so that would be a 2. And we say, how many times does 241 go into 222? Well, it doesn't. So we would have to then bring down the next column as well. And so we end up with how many times does 241 go into 2,221? Now I'm thinking, because we've got 241, sorry, if we multiplied that by 10, we would just be adding a 0 to the end. And so we would know that that'd be too big, but it would be close enough that I believe the number would be 9, and you can always check this. And so 9 would go into 2,221. And so we would have to put the 0 above because we've skipped that, and then we would put the 9 above the column we're currently working with. Now, multiplying 241 by 9, we would get 2,169. And so now we would just do our subtraction. 1 minus 9, well, we have to borrow. So we end up with 11 minus 9. Then we go 1 minus 6, can't do that, have to borrow. 11 minus 6, which is 5. 1 minus 1 is 0, and 2 minus 2 is 0. So we end up with 52. And so what this is saying here is that we have a remainder of 52. And so if we want to check this, we would then multiply 309 by 241. So we go 1 times 9, well, 1 times this whole number will just be 309. And then we can move to the next column, so we add a 0. And so we go 4 times 9 is 36. 4 times 0 is 0 plus 3. And then 4 times 3 is 12. Then finally we add 2 zeros because now we're at the hundreds place. And so we get 2 times 9 is 18. Carry the 1 over. 2 times 0, 0 plus 1. 2 times 3 is 6. Now we can choose to add on our 52 here as well, which is the remainder. So we can add all these together. So we get 9 plus 2, which is 11. Then we get 1 plus 6, which is 7, plus 5, which is 12. Then we get 1 plus 3, 4, plus 3, 7, plus 8, 15. Then we get 4 once we add up here. Then we get 7 once we add up here. And so we end up with 74,521, which is the same as our dividend. So it's a little bit trickier, but we just have to keep remembering to stick to the process and you will come out with the correct answer. So looking at translating word phrases to math notation, we need to understand that the word phrases of divided by, or if we want to be finding the quotient of or divided into, these are all examples of things that we can see in word problems when we want to be looking to use division. And so examples of this could be 12 divided by 4, the quotient of 12 and 4 divided into 12. These are all different ways to say the same thing. Just as you can see in the fourth column there, we have different ways of expressing that in terms of our mathematical notation. They're all equivalent. So if we want to translate and simplify, so the translate part is putting it into math notation. So we would go 51 divided by 17. And so we could just use our long division here. And so I know that 17 goes into 51 3 times. So 17 times 2 is going to be 34 plus 17 is 51. And so we can say 17 divided, so 51, divided by 17 is equal to 3. And I won't check this by multiplying, but 3 times 17 does equal 51. So now if we want to divide whole numbers in applications, so these are the exact same steps that I've given for the addition, subtraction, and multiplication lectures. And so basically we want to determine what we're looking for, write a phrase, so those word phrases from before that give us the information so that we can find out what we're looking for. And so then we want to translate that into math notation and simplify, which was the last thing we did. And then ultimately we want to write a sentence to answer the question. So keep these notes handy. This is I'd go as far as saying this is a generalized problem-solving approach that we want to use whenever we come to any application problems. So Cecilia bought a 160-gram box of oatmeal at the big box store. It's a pretty small box, but sure. She wants to divide the 160 grams of oatmeal into 8-gram servings. She will put each serving into a plastic bag so she can take one bag to work each day. How many servings will she get from the big box? So we want to look at what we're actually looking for. And so keyword here is divide into 8-gram servings. And so ultimately what she wants to find is how many servings she'll get from the box. And so the first thing I think is if we're dividing 160 into 8-gram servings, then we're going to be having 160 as the dividend and 8 as the divisor. And so I'd probably approach this in a long division question. And so I'd use the notation of 8, 160. And so I would then, I'll move very quickly with this, divide 8 into 16, and I get 2. Carry that down, get 0 and 0. The remainder, therefore, we have 20. So 8 times 20 is equal to 160. And so we could say that Cecilia would get 8-gram servings of oatmeal out of a 160-gram box. So that's a good example of a basic division worded problem. Key thing there is look for the phrasing, look for what you're supposed to do. Am I supposed to multiply? Am I supposed to add? What steps will I have? What am I actually looking for? And then how can I answer it as a sentence? Awesome. So that brings us to the end of our division lecture and the end of our real fundamental kind of lectures. So we'll actually be jumping into some algebra. And so really important that you get a good grasp of all of this. The important takeaways from this lecture are that division is basically repeated subtraction, just like multiplication is repeated addition, and therefore multiplication and division are inverses. And so something to really keep front of mind is that if you want to undo division, you can multiply. If you want to undo multiplication, you can divide. So that'll come in a lot of uses for algebra and further math. And so the other key thing is really trying to internalize that process of long division. And so the best way to do that is just practice. So I'll be uploading some practice problems and a long video of those. And so hopefully that is of some help. So if you have any specific feedback or you want anything done, chuck a comment below and subscribe to keep up to date with all of our latest videos.